Alright, so let me show you what I mean. We're going to look at the electrolysis of molten copper to chloride. Alright, this is the easiest way for me to illustrate to you how this whole electrolysis process works with the electrolytic cell in as straightforward a method as possible. Alright, so this is what happens. We're going to set up our electrolytic cell. So we have our two electrodes, and from the readings I sent you all, you would know that your electrodes are usually made up of platinum, which is, hella expensive because it's used to make jewelry and stuff. So the more popular one, the more low budget one is graphite. Same graphite that's in your pencil. And you remember, we know that graphite is an excellent conductor of electricity. Alright, so we have our electrolytic cell set up. This is our negative electrode, our cathode, and this is our positive electrode, our anode. And our electrolyte is going to be copper 2 chloride. Now, what are the ions that are present in copper 2 chloride? You have copper 2 plus ions and you have Cl minus ions. Now, because this is molten, what it means is that you have to have heat being applied to the reaction vessel. Why? Because remember, ionic compounds don't conduct electricity in the solid state. They only conduct when they are molten or in aqueous solution. So right now we're focusing on something that's molten. So to keep it nice and melted, we have to apply heat to it. Alright? So when we apply heat to the copper 2 chloride, it melts, and then we have copper ions, copper 2 plus ions floating around, and we have Cl minus ions moving around. And each of these ions is going to move to the respective electrode that it is attracted to. Alright, so your cations move to the cathode and become discharged. Your anions move to the anode and become discharged. If we didn't have the heat, the ions would not be free to move. The liquid would resolidify, and then no, ions are free. We don't have any movement. We obviously won't have any electrical current flowing. Alright? Sometimes, as I said to you before, you can get technical. You can put in a bulb into your circuit. Right? So you might put in a bulb into the circuit so that when current starts to flow, the bulb lights up. Right? Put in a switch, all those fancy stuff. If you did electricity before, then you would have been exposed to all those things. But for right now, sir is just trying to give you an overview, right, to aid with the reading that you would have done and the other YouTube videos and stuff that I would have sent to you. Alright, so when you have your ions moving to each electrode, there are a couple of things that you can get asked. For molten compounds, there are only 2 ions that are present, so life is pretty easy. But when you get to aqueous solutions, they may ask you which ion is being discharged. They can ask you to write a half equation for what is happening at each electrode. They can also ask you what you may see at each electrode. Okay, so you know that at the cathode, the ion that's being discharged, there's only one ion going to the cathode, and that's copper 2 plus ions. So at the cathode, copper 2 plus ions are being discharged, if I can spell. Alright, now how does an ion become discharged? When something is discharged, what it means is that it loses its charge. Okay, so how will copper 2 plus ions lose their charge? You want to get rid of the positive charge, so you need to have something that will cancel out the positive charge. The only thing that can cancel out the positive charge is the negative electrons. So this is what is going to happen. Cu2 plus ions are going to gain 2 electrons. So the plus is cancelled out by the minus to give you Cu. Normally Cu would be a solid, but because of all this heat, the solid is going to be melting to form a liquid. Alright, so this is what is happening. Copper 2 plus ions are gaining electrons to form copper atoms. Copper ions, copper ions, copper atoms. You have a charge, no charge. Okay? Something else that you can be asked is what redox process is taking place. Now, if you're gaining electrons, think about your oil rig. Think about your oil rig. When you gain electrons, oil rig, oxidation is loss, reduction is gain. So right now, the Cu2 plus ions are being reduced. So at the cathode, reduction is occurring. So let me ask you what redox process is taking place at the cathode. At cathode, reduction occurs. Alright? Now, if we look at the other electrode, you see that you have Cl minus ions. And Cl minus ions are moving to the positive electrode. So the negative ions are moving to the positive electrode. So, at the anode, look at what is happening. At anode, Cl minus ions are discharged. So, how will negative ions become discharged? Negative ions become discharged by losing electrons. So you're negatively charged already, yes, and you want to remove that negative charge to form something that is neutral. Alright, so the Cl minus ion is going to lose an electron to form a neutral Cl atom. But you know, as good chemistry students, that Cl is diatomic. So when one Cl atom forms, it will look for another Cl atom and pair up to give you Cl2 gas. Alright, so you're getting chlorine gas forming. Think about it now. You can take these two equations and you can actually put them together to make one. Alright, this Cl atom is losing an electron. Sorry, this Cl ion is losing an electron, to form a Cl atom, and another Cl ion is losing an electron to form a Cl atom. So two Cl minus ions are losing 2 electrons to form Cl2 gas. So whether you want to write these two equations or you want to write one equation with both of them merged together, it doesn't matter. But what I want is for you to appreciate and understand where this one comes from as opposed to where the first one comes from, because sometimes it's a bit quicker to just put both of them together and write one equation. So you have your copper 2 plus ions being discharged at the cathode, and you have your Cl minus ions being discharged at the anode. Yes? Now, at the cathode, reduction is occurring, and you know that reduction can't take place without oxidation. So look at what is happening to your chloride ions. Your chloride ions are losing electrons. Oil rig, oxidation is lost. So at the anode, oxidation is occurring. And the Cl minus ions are becoming oxidized. So if they ask you what redox process is taking place, and as a general rule, oxidation always occurs at the anode and reduction always occurs at the cathode. So you know what redox process will take place at what electrode. You know what ions are being discharged at what electrode. You have been able to write your half equations. Remember, these are the half equations. Half equations are equations that show you electrons being lost or gained. So that is your cathode half equation, and this is your anode half equation. Alright, so you have your half equations. The last thing you can be asked is what you may possibly observe at each electrode. Now, at the anode, you have Cl minus ions forming chlorine gas. When you form a gas, you automatically have effervescence. Alright? Now, what does chlorine look like? Chlorine is a yellowish green gas, so you will have effervescence of a gas being observed. And you know the test for chlorine gas. It turns blue litmus paper red and then it bleaches it. Alright, so all of that can come in with your test for gases and stuff like that. Alright, so your observation is at the anode, effervescence of a gas occurs. At your cathode now, at your cathode, freshly produced copper is kind of pink. So you may have a solid forming around the electrode that then drips off and falls to the bottom of the container. So a reddish brown solid, or if you say a pink solid, orange looking solid, freshly produced copper is pink, and then it becomes reddish brown after. Right? So that solid forms on the electrode and then it drips off and settles at the bottom of the container. Alright? So this is basic look at how you would answer an electrolysis question based on electrolysis of a molten electrolyte.